Alright guys, we're going to be on 5.4. I want you guys to open up a new piece of paper and write 5.4 at the top. You're going to write this along with it. Solving special systems of linear equations. Okay, remember you can always pause my video to make sure you write this down because I am going to go kind of quick just so your video isn't, 45 minutes long. Here's what we're doing in this lesson. I need you to be on page 226 in your book. I need you to take really good notes as we go through this. All right, here's the main point of this lesson. The lesson is telling us that sometimes a system of linear equations, remember we learned that that means it's two equations together, right? Like what we've been doing. Sometimes your system of linear equations can only have one solution, and that's what we've been doing for the past 2 weeks. The one solution is right here where they cross in the middle, okay? But sometimes there will be no solution. And what that means is the lines are parallel. They never, ever, ever are going to cross. Which means, it totally makes sense, right? I wouldn't have an ordered pair of where they cross because they never cross, okay? And then also, not only can we have some with one solution, no solutions, we can have an infinite amount of solutions. What that means is that the lines land on top of one another and they are actually the exact same. So if I graphed a line and then I went and graphed the line again and they landed on top of one another, that means everything on the line is a solution. It's where they cross, right? And they cross all forever. So that's why it's infinite amount of solutions. Let's go ahead and do some example problems so that you can see what, we all know what this looks like, but I want to do some examples so you guys can see what these two would look like, okay? All right, here's our first example. Y equals 3x plus 1, y equals 3x minus 3. Now there's a few ways we can solve this. One way is I can just graph them, okay? So let me graph them real quick. I've got some grid paper right here. Let me write these down. Y equals 3x plus 1. Y equals 3x plus 1. And then the other one was 3x minus 3. Okay. If I had a coordinate plane, how would I graph this first equation? Well, the first thing I do is I look at my y-intercept. What is the y-intercept? 1. So I'm going to go put a dot at 1. Then I say, what is the slope? The slope is 3 over 1, which means I'm going to go up 3 over 1. Up 3 over 1. Or I can go down 3, back 1. Down 3, back 1. Okay, so there's my line. Ugh. Good enough. How would I graph my second line? Well, first of all, where's the y-intercept? Y-intercept is negative 3, which means I will go down 3 on the y. 1, 2, 3. What is my slope? Slope is 3 over 1. We learned last chapter that if two equations have the same slope, they will be parallel. And so right away, I can just look at this. I didn't even have to graph it, honestly. If I would have seen that the slopes are identical to one another, I would have known that these two lines are going to be parallel. So watch this. Up 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Or I can go 1, 2, 3 back 1. Draw my line. Now, if I, had a ruler and didn't have craziness going on, can you guys very easily see that those are parallel lines? So you kind of have to, if you think about it, you don't have to do a whole lot of work. If you just saw that these were the same slope equals parallel lines. I'd write that in your notebook, by the way. So back to our book. Solve the system of linear equations. If they are parallel, do I have a solution? I do not. So it would be no solution for these two. okay? If you're somebody who's like, graphing is great and all, but like, Mr. Ringler, I don't have graph paper all the time. It's kind of a pain because there's human error. Watch this. I'm going to hit the back arrow a whole bunch so I can have my original equation ready to go. We're not going to graph these now because sometimes graphing is just not ideal, right? We have also learned other ways to solve a system of linear equations. We can graph it, we can table it, or we can do the fun ones called substitution and elimination. These are set up perfectly for substitution. So I'm going to substitute. I'm going to substitute this in for y. And my new big equation will look like this. 3x plus 1 equals 3x minus 3. To solve this, I need to get my x's on the same side, which means I'll subtract 3x, subtract 3x. 3x minus 3x cancels out, so I'm left with a 1. But now look right here. 3x minus 3x is canceling out again, which means I'm just left with my negative 3. Is 1 equal to negative 3? No, they are not equal. If this happens, then you know the answer to your solution is no solution. Okay? So if you're somebody who doesn't like to graph, remember there's always all these different options. I personally love substitution. Substitution for me is just quick, it's easy, and right there, bada bing, bada boom, I can tell these are not going to work. Okay? I'm going to erase my paper. Remember, you can always pause the video if you need me to slow down a little bit so you can write these down. Now, sometimes things might have solutions, but it goes on forever and ever and ever. So let me find you an example for that. Let's do number 6 on this page right here. Write this in your notebook. I'm going to rewrite it on my notebook too. 2x minus 4y equals 10. 2x minus 4y equals 10. And then the second equation was negative 12x plus 24y equals negative 60. Okay. You know, I like to do substitution. I just feel like substitution is super quick, super easy. This also looks like one, though, where I could do elimination. I could multiply this whole top row by negative 6. If I multiply this whole top row by negative 6, my new equation would be negative 12x plus 24. Remember, I'm doing the distributive property. And then this would be negative 6 times 10, which would be negative 60. I could do it this way, because now look, I'm going to rewrite my second equation below. So it's going to be negative 12x plus 24y equals negative 60. Okay, guys, before I do anything, this is crazy, just look at this. Is this equation identical to this equation? Like, everything's the same. The negatives are the same, the positives are the same, everything is identical, right? If everything is identical, watch what's going to happen. So I need to eliminate, correct? So I'm going to say plus. Let's just see what happens. Negative 12 plus negative 12, that's going to be positive 24x. And then 24x plus positive 24y plus positive 24y. Oh my gosh, you guys, that's going to be 48y. And then negative 60 plus negative 60, that's going to be negative 6 and 6 is 12, 120. Okay, here's my problem. Did I eliminate anything? No. Well, some kids are like, well, Mrs. Ringler, you taught us that if something didn't eliminate by adding, what should we try doing instead? Subtracting. Well, okay, let's try that instead. Let's subtract. What is negative 12x minus negative 12y? Remember, that's going to be like this, and that's going to make a plus. So it's negative 12x plus 12x. That's going to be 0x. Gone. Well, okay, how about this? What is 24y plus negative 24y? Oh no, well that's now gone as well. They both canceled out. And then what's negative 60 minus negative 60? It's like saying negative 60 plus 60, which is gone. 0 plus 0 equals 0? I mean, yeah, sure it does, but here's the problem. I didn't eliminate just one thing. I eliminated all the things. Here's what I want you to see. You don't have to go through all that work. You don't have to check it with all these different methods. If your equations are identical, you can just stop, because that means there are infinite solutions. Infinite. So I'm going to say infinite solutions. How do I spell that? I-N-F-I-N-I-T-E. Infinite solutions. Write that down in your notebook, right? Infinite solutions means the two equations are identical. Nice arrow, Mrs. Ringler. Okay, so let's talk about the big differences we saw. If I get a solution that looks like this, negative 3 equals 1, that means there's no solutions. That's like, nope, nothing. However, if I get one like we did right here for number 6, where we noticed right away that these equations actually are the same thing. I noticed that because I did my elimination. If you notice they're the exact same things, you're going to have infinite solutions, okay? Now, another thing, though, is some kids are like, well, Mrs. Ringler, that's great, but seeing this equation, what if somebody didn't want to do elimination? What if somebody wanted to do substitution, for example? Well, that's totally okay, you guys. I'm going to go back, hitting that undo arrow 100 times. What happens if you see these and maybe your automatic response wasn't, oh, I will do elimination? What if you were thinking, oh, substitution, because I love substitution. Let's try and see what would happen if I did substitution. For one thing, I need to get a variable by itself. I'm going to get the, what would be an easy one to get by itself? Probably the 4y, get that on the other side. So I'm going to plus 4y. The reason why I chose 4, you guys, instead of getting rid of the 2x, is because now if I divide everything by that 2, it's going to be nice numbers for me. So my new equation will be, bye-bye, x equals 10 divided by 2 is 5. 4 divided by 2 is 2. Keep your y. Now, can I substitute this in for x in my second equation? It's going to be a long little process, but let's do it. I'm going to rewrite my new equation. It's going to be negative 12, parenthesis, because it's being multiplied, 5 plus 2y, parenthesis, plus 24y equals negative 60. Okay, distributive property first. Negative 12 times 5 is negative 60. Negative 12 times positive 2y is negative 24y plus 24y, oops, make my 4 look more like a 4, equals negative 60. If I said get y by itself, the first thing some of you would see is, oh, I see like items, Mrs. Ringler. Negative 24y plus 24y. Oh, well, those cancel out. That's 0, which is nothing. So what I'm left with is negative 60 equals negative 60. Now, is that a true statement? Yeah, well, negative 60 is negative 60. So here's the problem. There's no more variables to solve for, which means there is an infinite amount of solutions. So remember, we had the one over here that said negative 3 equals 1, which is not a true statement. So we said, no way, Jose, no solutions. But then over here, when I did number 6 the other way, I got negative 60 equals negative 60. That doesn't mean there's no solutions. That means there's an infinite, forever amount of solutions, okay? So this section, this chapter, all I need you to understand is that you can solve these different equations by doing many things. You can either graph, you can either substitute, you can either eliminate, but you need to know is that sometimes you're going to get one solution, which is our, x comma y, which is wonderful. We've been doing that for weeks. or you're going to get no solutions, or you're going to get an infinite amount of solutions. Your homework for this lesson is I want you to do numbers 1, 2, and 3 on page 226. And then I also want you to do number 4, 5, and 6 on page 227. We just did number 6, so that shouldn't be too bad for you. Just make sure you write down all the steps. After you do those 6 problems, I do want you to go to page 228, and I want you to go and do 8, 9, and 10. Oh, sorry, not 10. Let's just do 8 and 9. It just says to solve the system of linear equations and then to check your solution. Don't worry so much about checking your solution. Checking your solution just means like after you've done it with either substitution or elimination, then go graph it and see. But I really don't care. I feel like you guys can just do substitution or elimination. Okay? All right. So if this lesson was a little tricky for you, what I'd suggest you go do is stop the video, go back, rewatch it, make sure your notes are very detailed, make sure that you are writing down questions that you do have so that maybe I can address them on Friday. All right, guys, good luck with this lesson. And remember, you do not turn in your homework digitally. I will be back Friday to check it in person. So your homework is 1 through 6, 8, and 9. All right, bye, guys.